This is Prime Concept. You're welcome once again to my channel. So we are about to kickstart with our revision class for Chem 107 as Chemistry Practical. It's a very important class because most of you will be writing this exam tomorrow. So and it's very important that you participate in this revision, very intensive revision class from the very start of the class, because I would start this class. We have two phases of, or let's say three phases we're going to look at. So we're going to look at the quantitative analysis, and then we're going to look at the qualitative analysis, and then we're going to look at problem solving. So these are the three areas we're going to consider. I'm going to be pointing out a whole lot of things that you need to know. I'll be giving you a lot of mnemonics that can help you remember these things, because you have a whole lot to learn in Chem 107 and it might be difficult for you to cram some of these things. So I'll be giving you some short tips that can help you remember these major areas in this Chem 107 exams. So before we start, I would like you to please hit the like button. If you are joining us and you are yet to subscribe to this channel, please hit the subscribe button. It's a free tool to use. You don't have to pay. Hit the subscribe button, hit the like button. We are doing a lot on this channel. We are having series of marathon intensive revision classes. Now, after our today's revision on Chem 107, by tomorrow we're going to do Physics 101 revision. That is going to be very drastic, very radical, very intensive. So do well to subscribe, you need it. And quickly try to share this video with your friends. Tell them that Prime Concept is live. We want to start. Let me see. Prime Concept is live. Prime Concept is live. So indicate your presence. Thank you. You're welcome. Okike, thank you. Okike, thank you. Creative, thank you. Uchechi, thank you. Ekene, thank you. Welcome. You're welcome. You're welcome. Elvin, welcome. Ekene, welcome. Achufusi, welcome. So we're going to start. Justice, you are welcome. Salubrios, you're welcome. Original Boy, you are welcome. Benedict, you're welcome. Ezuka Oledo, you are welcome. Blessing, you're welcome. Thank you. I can see your work. Hit the subscribe button. Share the video. Blessing Uche Noya, you're welcome. Raphael, you're welcome. So you are all welcome. Do well to share with your friends. And if you are joining and you're yet to subscribe, hit the subscribe button. All right, let's quickly move because we have a lot to do. First, we want to start with quantitative analysis. Quantitative analysis. Now, when you talk about quantity, of course, we have Chem 107 is divided into two parts, is one of the things you should know. One part of Chem 107 is quantitative analysis. And under the quantitative analysis, we'll be dealing with basically acid-base titration. So Chem 107 is into two parts, quantitative analysis and qualitative. So from the word quantitative, it simply tells you that you're trying to find the quantity of something. That's why you call it quantitative. You're trying to quantify something. So, and in quantitative analysis, we have different areas, but for the sake of Chem 107, we'll just be interested in acid-base titration, all right? So, which we still call this volumetric analysis. We can still call it volumetric analysis, a method that is used in obtaining the volume of a substance. So that is volumetric analysis, all right? Now, very quickly, when you're dealing with quantitative analysis, there are certain terminologies that you need to know. Now, all these things, anything I'm giving you is very important. Just like I told you in Physics 107, take every point I'm giving you important. And just to add, so that when you're studying, you become very conscious. One of the ways of passing exams is not by studying randomly. is by studying. You can see somebody that studies just for a short time, and that person will do better than that person that has been studying all through. So these short hours of revision we're going to have, there are people that this will be their first time of revising Chem 107, and they will do marvelously well. Why? Because this study and revision is going to be very strategic. Now let me tell you, for Chem 107 exam, mark my words, you would meet about 30 questions. It is usually either 30 questions or 40 questions, but I believe it's going to be 30 questions this time around. Now, in that 30 questions, about 15, or let's say 15 to 12 of those questions to 10 of those questions are going to be on calculations. So, and that has been a complaint or a challenge for students most of the times. So mark this, take note of it. About 15, 12 to 10 questions are going to be on calculation. So it means most of the times your challenge is going to be time frame. So that's why this revision is important, so that we're going to be looking at those possible areas of calculations that come from exam, and I'll give you other tips from other areas, and then you go back and explode in your exams. Now, there are certain terminologies that you should know in quantitative analysis. One of them is what you call a standard solution. Standard solution. So what is a standard solution? From the word standard, it should tell you that this becomes a reference. A standard solution is a solution whose concentration is known. A standard solution is a solution whose concentration is known. That is what you call a standard solution. And we have two types of standard solution. We have the primary standard solution and we have the secondary standard solution. So take note of this. I'll be fast. I'll try to be a bit fast. You have the primary standard solution. One of the properties of the primary standard solution is that it should have a high percentage purity. It should be very high. It should have high percentage purity. That's one of the things you should know. It should not be hygroscopic. Should not be hygroscopic. These are properties of a primary standard solution. So that is a standard solution. Now, for example, exam can give you, let's say HCl is titrated. HCl is titrated against 2 molar sodium hydroxide. HCl is titrated against what? 2 molar sodium hydroxide. Determine the concentration of HCl. Determine the concentration of what? HCl. So you notice that you have two substances here. One of them is HCl, the other one is sodium hydroxide. They gave you the concentration of sodium hydroxide and they want you to determine the concentration of HCl. So what it simply tells you is that your standard solution is what? Sodium hydroxide. So exam would ask you, which of these substances is the standard solution? So the standard solution here is what? Sodium hydroxide. So that is the standard solution. Number two thing, terminology you need to know, is what you call molarity. Molarity. Molarity is actually what you also know. You can still call it concentration. Or let me put the better word. If you don't call it molarity, you can also call it molar concentration. So it's either you say molarity or you say molar concentration. Now, what is molar concentration? Molar concentration is the amount in mole. Take note of that. It is the what? Amount in mole of a solute that is present in 1 dm cube of a solution. It is the amount in what? Mole of a solute that is present in 1 dm cube of solution, not solvent. I don't know. If you need me to be writing most of these definitions, please indicate in your comment section. But if you need me to just keep explaining, indicate so I will know what I'm doing. But I think I need to be fast. So that is molarity. So it is amounts measured in what? Mole of a solute that is present in 1 dm cube, or you can say 1000 cm cube of a solution. That is molarity. So, and the unit of molarity is actually mole per dm cube. Take note, not mole per cm cube. So this particular unit, sometimes if they don't want to write it in this long form, they will just use the symbol capital M to represent it. So it means if you see something like this, 2 capital M, what are they talking about? They are talking about molarity. Now see what exam likes to do. Rather than giving you this kind of values, they can just give you something like this, capital M over 2. Of course, these two things are not the same. This one means 2 mole per dm cube. This simply means 2 mole per dm cube. That's what this means, right? Now, but they give you something like this again. What does this mean? Very simple. This actually means 1 over 2 molarity, or you can simply say 1 over 2 mole per dm cube. So that allows them to confuse you by writing something like this, and somebody will jump and say it is 2 mole per dm cube they're talking about. No, this is actually same as half mole per dm cube, or you can say 0.5 mole per what? Dm cube. That is molarity. That is molarity. Now we also have what we call mass concentration. That is number 3. Mass concentration. So if we have molar concentration, we also have what? Mass concentration. So what is mass concentration? Mass concentration is the amount in grams. It is what? Amount in what? Grams of a solute that is present in 1 dm cube of what? Solution. That is mass concentration. So this one measures the amount in grams. This measures the amount in what? In moles. Thank you. So, and what is the unit for mass concentration? The unit is gram per dm cube, not cm cube. Concentrations are never measured in cm cube. They are dm cubes. I hope this is very clear to you. Now, molar concentration and mass concentration have a relationship. They have a formula that connects them. And what is that formula? The formula is molar conc, which is actually denoted with capital C. Molar conc is mass conc over what? Molar mass. That is molar concentration. It is mass concentration over molar mass. This is not some strange formula. It's what you actually know. Think of this formula. Number of mole is mass over molar mass. Number of mole mass over molar mass. That is where this formula comes from. So number of mole represents molar conc in this case, and mass is the mass conc and molar mass. So you don't have to cram some strange formula still coming from this place. So you can be given a simple question. Let me give you an example. Yeah. Say you have to tell you 1.5 grams of sodium hydroxide is present in, let's say, 250 cm cube. Stop. What is the mass conc? So I have this question. Can anybody attempt to solve this question? Can anybody attempt it before I solve quickly? I want to give you 1 minute to solve it, then I'll solve quickly. Quickly. Okay. I'm seeing your comment. I should be writing, so I'll try to be writing. Be explaining, sir. Okay, I'll be doing both. So I have a question I want you to attempt to. Remember, this is exam revision. So you have to be solving. It's very important. You have to be solving. Those of you that want to join this channel as special members, you can see there's a join button, which is very important, especially for second semester. You can hit the join later on. Join this as a special member. Here you'll be getting special videos and tutorials from Prime Concept. Please, if you have joined this, do well to hit the like button. Subscribe to the channel if you are yet to subscribe. We have a lot more of revisions coming up. Hit the like button. We have 61 persons. Hit the like button. That is your way of supporting us and encouraging us. Hit the like. subscribe. If you are yet to subscribe, push it up, push it up. Now let's solve this together. Now, they gave us 1.5 grams of sodium hydroxide is present in 250 cm cubed. What is the mass conc? I'm going to solve this very directly. Now watch. The mass concentration we just defined, we said it is the amount in grams that is present in how many dm cube? 1 dm cube, or 1000 cm cube. That is mass conc, the amount that is present in 1000 cm cube. Now they gave us the amount that is present in only how many cm cube? 250. It means that this is not the mass conc. So let us ask ourselves, if 1.5 gram is present in 250 cm cube, is that our mass conc? No, because for it to be mass conc, it has to be present in 1000 cm cube. So you now say, okay, what mass would be present in 1000 cm cube? What mass would be present in 1000 cm cube? That mass that will be present in 1000 cm cube actually is our what? Mass concentration. So what do? I'm going to cross multiply. So I would have 250 times x, which is 250x, equal to, I would have 1.5 times 1000. Then I would have that x becomes 1.5 times 1000 divided by what? 250. So if you punch this, tell me what it would give us quickly. Punch, punch, punch. You have to be actively involved. Punch. What do we have? So it is 6. So this is going to be 6 grams per what? dm cube. So it's going to be 6 grams per dm cube. I will give you another question. So we have this. See this one. They said, how much sodium carbonate would you weigh? How much sodium carbonate would you weigh to prepare n/20 sodium carbonate solution in 100 cm cube volumetric flask? So I'm giving you 30 seconds to attempt this, and then I'll solve. At any point, if you have any question, please do well to drop it in the comment. I'll be checking and I'll be responding to your question. So once anyone is not clear, do well to drop a question and ask me. I'll be checking it. All right, so I'm giving you 30 seconds. Let me read through the comments. 30 seconds to solve this. If you have a question, drop it in the comments section. So quickly, oh, somebody has solved. Aja said 0.53. My God, that is very fast. Okay, these other people got the previous question. Thank you. Israel got the previous one. Good News got the previous. Amarachuku got it. Uzoma got it. All right. Please, those of you that are joining, 82 people present, hit the subscribe button. Hit the like button. It's important. It's not a big deal. Please hit it so you don't forget. Just click subscribe, click the like. Support this channel. This is one of the fastest growing channels now. Hit the like button, hit the like button, hit the like button. Okay, let me solve. So we have, they said, how much sodium carbonate would you weigh? Something you are weighing has to be what? Mass. You don't weigh mole. You don't weigh what? mole. So what you weigh is mass. So it means they are asking you how much mass will you weigh to prepare this. So what does this represent? This represents the molar concentration. It represents the molar concentration. So remember I told you molar concentration is denoted by the symbol capital C. So molar concentration is 1/20. That is what they gave us, 1/20, for which if you punch this 1/20, that's going to give you 0.05. 0.05. That is the molar concentration. Now, solution in 100 cm cube. So the volume given to us is 100 cm cube, volumetric flux. So we are looking for what now? We are looking for mass this time around. We are looking for mass, right? Now, what are we going to do here? Very simple. We'll be doing this class touching every necessary areas. I may not go sequentially, but I'll be touching all the exam necessary areas. So one of the things I want you to know is that there is a relationship between number of mole and concentration. And that relationship is number of mole is equal to CV. Number of mole is equal to what? CV, where C is concentration, V is what? Volume. And this volume has to be in dm cube. N equals CV. This volume, if you are using this formula, take note that the volume should be in what? dm cube. Or if you don't want to use it that way, you can say N is equal to CV over 1000. If you are using this one, then this volume will be in cm cube. I just hope you understand the difference. If I want to use this formula, then make sure that your volume is given to you in dm cube. But if you want to use this down one, where you can see over 1000, make sure that your volume is given to you in what? cm cube. So don't convert again. So decide which one is best for you to use. Now, and we also know another formula, that mass, or rather number of mole, is equal to mass over molar mass. You also know this formula. Number of mole is what? Mass over molar mass. So which simply means that mass is equal to number of mole times molar mass. So we're going to start with this formula. I'm going to start with this. We're going to start with that. So the number of mole from this formula is concentration, which is what? 0.05 times the volume is given to me in cm cube. So that's why I prefer to use this. My volume is what? 100 divided by what now? 1000, right? So what is my number of mole going to be? My number of mole is going to be 0.05 times 100 divided by 1000. So this is going to be 0.005 mole. That is my number of mole, 0.005 mole. Is that what we are looking for? No, we are looking for mass. And that is why I'm going to use this formula. Mass is equal to number of mole times molar mass. So what is our mass? Our mass is number of mole. Now, remember the substance we are dealing with is sodium carbonate. So we need to find out the molar mass of sodium carbonate. So how do we find out the molar mass? It is going to be, they will give you all these things in exam. So it's going to be 2. It's going to be 2 for sodium. That is this 2 you're seeing outside. Then the atomic mass of sodium is 23, plus carbon is 12, plus oxygen here is how many? Oxygen is 3. So plus 3 into the mass of one oxygen, which is 16. So if you add up this, it will give you the molar mass so that we can use it. So this is going to be, this 46, this 48, 48 plus 46 plus 12, that is 106. So the molar mass is 106. So I'm going to use it here now. So my mass is going to be number of mole, which is 0.005, times my molar mass, which is 106. So my mass will be 0.005. So this is what I have, 0.53 grams. So that is my mass. There's still another formula we can use for this, which you call solubility formula. So quickly screenshot this. I will give you the solubility formula in case you want to just go straight. So you still have what you call solubility formula, which is concentration equals mass over molar mass times what? 1000 over the given volume, of course, in cm cubed. We can use this formula and get what we need straight. This is called solubility formula, right? Yes. Now, I hope you screenshot so that I can use this to solve. I believe you screenshot. Now watch. Say we want to use this formula, I will just make mass the subject because that's what I'm looking for. So remember, this thing is the same thing like this, n times 100. So watch. What I'm going to do is I'm going to cross multiply this volume times molar mass times C, right? So C times molar mass times volume will be equal to mass times 1000, right? So that if I make mass the subject, mass is going to be C times molar mass times volume divided by 1000. So this is going to be, want to put everything once. What is my concentration? 0.05. What is my molar mass? 106. What is my volume? 100. What is then, what we have under is 1000. So if you use this and punch, you get your answer straight. You get your answer straight. So let me confirm. 0.05 times 106 times 100 divided by 1000. So you have the same answer, 0.53 grams. So if it is clear to you, quickly hit the comment, say it is clear. I will move on. Say it is clear. Say it is clear. Hit the, tell me if it is clear and I'll move on. Quickly. All right, it's clear. Thank you. Hit the like button, hit the like button, hit the like button, hit the like button, hit the like button. We are doing a whole lot. We are doing a whole lot. Now we have so before we move further in these calculations, I want to quickly mention something that you need to know now, which is our indicators. Now, when you are doing titration, you need an indicator to do your titration. Of course, if I ask you what are the indicators you know, you would mention something like methyl orange, phenolphthalein, bromothymol red, bromothymol blue, and so on. So these are indicators. Now, first, what is the definition? Exam would ask you. I'm telling you, anything I'm telling you here, take it very serious. Now, what is an indicator? Indicator. An indicator is an organic acid, is a weak, it has to be weak. So an indicator is a weak, you said I should be writing, it is a weak organic acid or base that gives color changes in different solution. So it is a weak organic acid or a base. So an indicator can be an acid, an indicator can be a base, but the major thing is that it should be weak. It is not a strong acid or a strong base. That is an indicator. And there are common indicators you need to know, and their color changes. There are certain indicators you should know, and their color changes. Exam would ask you all these things. That is what they'll be asking you in OBG. That's what they'll be asking you. So you need to remember those things. So one of them is methyl orange. You need to know it. Another one is what? Phenolphthalein. You need to know phenolphthalein. Another one is what now? Okay, let me put it this way. After methyl orange, let me use methyl red first. So you still have methyl red. Then you have phenolphthalein. You have phenolphthalein. You have bromothymol. Bromothymol red. You have bromothymol. Bromothymol blue. Bromothymol blue. Now, these indicators in acid, they have a certain color they indicate in acid. In neutral solution, they have a certain color. Then in alkaline or base, they have their color. And you need to know these things. It's very important that you should know. Now, for methyl orange, see what you need to remember the color changes. Now, notice how I have arranged these things. See how I've arranged it? I started with acidic medium, then neutral medium. That is to say, when it is neither acidic nor basic, it is neutral. So in neutral medium, that is when you have completely neutralized. Then in alkaline medium, what are the color changes in this different medium? Now, for methyl orange, there is something we used to learn before from primary and secondary school about colors, which is what we call Roy-Wave. Do you remember this? Roy-Wave. Yes, I'll pick this. This gives me my answer. So for methyl orange, in acidic medium, it is red. It is what? Red. In neutral medium, it is what? Orange. Then in alkaline medium, it is what? Yellow. So I hope this helps you to remember Roy in Roy-Wave. It helps you to remember that. Now, in methyl red, you also follow the same Roy. So it's going to be red, orange, and what? Yellow. So I believe you can't forget that. Roy-Wave. Then for phenolphthalein, what do I use to remember? I use CPP to remember. I use what? CPP. Remember, it is acidic, neutral, and alkaline. Once you remember this order, follow these mnemonics. You will not forget it. CPP. So what does C? What does C mean? C means in acidic it is colorless. 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 Then in neutral medium it is pink. Of course, light pink. Light pink. It is light pink. Pink is what you need to really know. Then this, it is what? Deep pink. Deep pink. I hope this helps you. And this is what we're going to be doing both in salt analysis. I'll be giving you a lot of mnemonics that can help you remember these things. Then for this one now, so this one you have YGB. YGB. For this one you have what? YGB, right? Yes. So in acidic medium you have it is yellow. In your neutral medium it is green. It is green. And in this medium it is what? It is blue. It is blue. Then bromothymol blue. You have it is what now? Yellow. Sorry, this one. So this one is yellow. This one is green. This one is blue. So the difference between both of them now, just that this one, there's no color for this particular space. So you can still use this to remember both of them. So I believe these color changes would help you in remembering indicators. Quickly, I want to rub. If you are good, say move on. If you are good, say move on. I want to go to the next point. Quickly. The next point. Say move on if you are done. Screen that. Say move on. Thank you. Israel, say move on. Move on. Thank you. I hope you are following what we're doing. Hit the like button. Hit the subscribe if you are yet to subscribe. Hit the subscribe if you are yet to subscribe. Hit the subscribe button. Don't forget, support this channel. Now, the next thing, after learning the color changes in indicators, you also have choice of indicators. Now, how do you know the choice of indicators? Exam would ask you that if this acid is titrated against this base, I will give you a typical exam question. What is the best indicator to use? You see those kind of questions. So you need to know indicators and their choice for your different acid. Remember, you have a strong acid, you have a weak acid, you have a strong base, you have a weak base. So we're going to do this in this order. So we're going to say strong acid versus strong base. I'm going to start now. Notice the pattern I'm going to use. Strong, I'm going to use acid as my starting point, base at the ending. That is the pattern, acid before base. Now, strong acid against strong base. The next is going to be strong acid against weak base. Abi? The next is going to be weak acid against strong base. Are you seeing my pattern? It is acids on this side, base on this side. Then the next is going to be weak acid slash what now? Weak base. So this is the pattern. So if you have this, what are the choice of indicators you want to use? For strong acid, strong base, it is any indicator. It is what? Any indicator. So it means for strong acid, strong base, you can use methyl orange, you can use phenolphthalein, you can use methyl red, you can use any one. So any indicator is okay. So I'll write choice of indicator. Choice of indicator. So any indicator is okay. Now strong acid against weak base. What will you use? Methyl orange. Methyl what? Orange. Then when you have weak acid against strong base, what would you use? Phenolphthalein. Phenolphthalein. Then when you have weak acid against weak base, no suitable indicator. No suitable indicator. Now, how do I remember this? Because I have a lot of things to remember in this exam. The simple thing I give is use AMP. AMP, none. Use what? AMP, none. Do you know amplifier that you use in your church? Amplifier. So use it to remember. AMP, none. What does it mean? For the first one is A, any indicator, M, methyl orange, P, phenolphthalein, and none of them, none of the above. That's why I say arrange it in this order. Strong acid, strong base. Strong acid, weak base. Weak acid, strong base. Weak acid, weak base. Once you follow this order, then don't forget it is AMP, none. So any, methyl orange, phenolphthalein, and none of the above. If this is very helpful to you and very clear, tell me very clear and helpful. Then we'll move on. Quickly. If it's very clear and very helpful, tell me quickly. Let's move on. I'm waiting. If it is very clear and helpful, tell me. Let's move on. Thank you. So we're going to move to the next concept now. We're going to move to the next concept. So we want to look at, of course, your titration. Now, one of the things you would meet, like I told you very well, they will give you titration table, and they will ask you, using this table, calculate this. So it means you're not going to run from titration calculation. You see these calculations very well. So, and remember how your titration table will always be. It's always going to be your burette reading. Abi? It's going to be your burette reading. Of course, you don't need to cram this table. You don't need to cram how to arrange the table, because they will give you the table in exam. Then they will ask you to calculate from that table. So you have your burette readings, you have your final reading, you have your initial reading, and then you have your difference. Anyhow, they may decide to arrange this in column form. Anyhow, don't allow it to confuse you. Just notice your final, notice your initial, notice the difference. So this, they can call this rough. Call the next one, they can call it your first reading. You can call this one your second reading. They can still call this first, second, third, anyhow they want to do it. So, but just notice that the concept is what? The same. So you would see something like this in your exam, and they want you to deduce some things from this table. Now, of course, what is your final reading? Your final reading is the final mark on your burette, just to add in your titration. Two major apparatus that you use. One of them is your burette. The second one is your conical flask. Two major apparatus you use is your what? Your burette, and the second is your conical flask. They can ask you, which solution do you put in your burette? Which solution is usually present in the burette? It is your acid, at least for your level. When you go higher, you can put base in the burette. But for your level and for what you learned in Chem 107, solution that is usually present in your burette is your what? Your acid. Solution that is present in your conical flask is your what? Base. For some of you that have forgotten, this is your conical flask. This is how your conical flask is. That's one you drop on top of the thighs. This is your conical flask. What you put in this particular apparatus is your what? Base. Again, they will ask you, before you start your titration, of course, you know that you need to ensure that your conical flask is neat. What do you use to rinse your conical flask so that you can ensure that it is neat? Who can tell me? Drop it in the comment section. Also, what do you use to rinse your burette? This is your burette. That long thing you have like this. That long thing you have like this. This is your burette. Then this is your conical flask. This is how your titration setup is. So what do you use to rinse your conical flask? What do you use to rinse your burette? Tell me. If you know the answer, quickly drop it. Of course, let me tell you, then we can confirm your answer. The solution you use to rinse your conical flask is water. You use water to rinse your conical flask. Why do you use water to rinse your conical flask before you start your experiment? So that, because if you use any other solution, say you use base or use any other solution, you might dilute that base that you want to use. So in order not to dilute the solution that will be in your conical flask, it is advised to rinse it with what? With water. Now, for your burette, what do you use to rinse your burette? You use the solution that will be present in the burette to rinse it, which is your what? Acid. That is what you use to rinse your burette, the acid, not water, not base. You rinse it with your acid. And of course, you know, if you want to put your base in your conical flask, you use a pipette to suck it. You pipette your base and put it in your conical flask. All what I've said now, they are exam questions, and I expect that you are writing. You are writing. And make sure you even come back again and watch this video as many times as you can before entering the exam hall. So I believe you've taken note of this point. So your final reading is when you start opening this. Remember, when you are doing your titration, you open this, it will drop down. You open this, it will drop down. When you now get your endpoint, you stop. So when you get your endpoint, you take the reading. That reading is your final reading. So let's say your final reading is 25.50. Then let's say this one gives you 25.55, and then this one gives you 26 point, okay, let's say 26.55. Let's say this is what you have as your different readings, and your initial, let's say it is 0.00. This one is, let's say it is 0.50. Then let's say this one, okay, let's say this one 0.00, and let's say this one is this one is 5.00. Let's say this is what you have. Now, if you want to get the difference, because this difference is what you'll be needing. If you want to get the difference, what will you do? This minus this. So it gives us 25.50 minus this. What will it give us? 25.50. This minus this, 25.55. This minus this, what will it give us quickly? I think to give us 21.55. 21.55. Now, this is what you expect. Why am I doing this? Exam would also give you a table like this and leave some missing points. They will leave some points blank and they want you to find it. So please, this is a time to be very intentional about your preparation. If you follow every explanation in this video, it's possible for you to get even 30/30 in that exam. No big deal, because most of your questions will come around quantitative analysis, your calculations. So now we have filled this table. Exam, you can go to exam hall tomorrow. They would clean this part. They will clean this part. They will now label here as A, label here as B. They will ask you to find A and B. They will ask you to find what? A and B. So how do you think you would find A and B? Very simple. For you to find A, you already know that to get this place is usually final. Your difference D is usually final minus initial. That is the formula. Difference, which is the last part, is usually final minus what? Initial. So in this case, which one is missing? What is missing is initial. So I will make initial the subject formula. So it means, remember this minus I. If it crosses to this place, it becomes I equal to what is left here? F. Now when this D crosses, it becomes minus D. So it means if I want to get A, I would simply say the final. What is the final? 25.50 minus the difference, which is what? 25.50. So if you subtract this, it will give you what? 0. So it means that A is 0. I hope you understand. Yes. Same thing is applicable to B. If you want to get B, you would notice that what is missing in this case is what? Final. So it means you need to make final the subject formula here so that you can find B. And to make final the subject formula here, I'll just cross I to come and meet D. So it means I'll have D plus I equals final. Then you'll be able to get final. Now, before I move, I will give you another question. But before I rub this table, I want to explain to you, there's something you call concordant values. There's something that is called what? Concordant values. What are concordant values? Concordant values are values that fall in the range of less than or equal to 0.1. They are values that falls in the range of what? Less than or equal to 0.1. Those are the values you call concordant values. So concordant values can be 2 in your table. It can be 3 in your table. It can even be 4. So nobody says concordant values must be only 2 values. Now, what do we mean by this to help you? You check in your difference, because where you check for concordant is in your difference. Now, we want to check values that are in this range of 0.1 or less than or equal to 0.1. When we say less than or equal to 0.1, it means that the difference can be 0.1 or the difference can be less than 0.1, that is 0.05, right? Yeah. So let's check this. What's the difference between these two? 25.55 minus 25.50 is 0.05. So the difference between these two is what? 0.05. 0.05. 0.05 is already less than this. So it means these two can be concordant. Let's check between these two. The difference between these two is very far. If you check it, 25.55 minus this, the difference is far. Let's see. 25.55 minus 21.55. What's the difference? The difference between these two is 4. You check the difference between these two again, it's still very far. So it means that your concordant values are this and this. These are your concordant values. So what are concordant values? Values that are either 0.1 or less, can be 0.05, right? So values that are either this or less than this are what you call what? Concordant values. Can be 0.0 whatever, as long as 0.0 something else, as long as it is less than what? 0.1. So if this is clear to you, say move on. Let me see the comment section. Say move on. Thank you. We have 83 persons, 84. This is now equivalent. So if it is clear, say move on. Somebody say, when do we apply the plus or minus 0 is the same thing. It's the same thing. The same thing. It's either above it or less than it. It's the same thing with what I've just explained. So you can say plus or minus, the same thing. It means it can be above or so it's same concept. So move on, move on, move on, move on. Okay. So screenshot this. If you are joining us, you are yet to subscribe, do well to hit the subscribe button. Now you've understood concordant values. Another thing you want to be able to find, because they will ask you from your table, is what you call average volume of acid used. Average volume of acid used will always be gotten from your table. So the average volume of acid, I will call it VA as volume of acid. The average is going to be from your concordant values. If you look at our table, you will notice that our concordant values are this and this, only two of them. So it means that my average is going to be 25.50 plus 25.55 divided by what? Now, how many concordant values do I have? I have 2, so I would say divided by 2. If I have 3 concordant values, if these values, this plus something else, if there are 3, then I'll divide by what? 3. So it means that in this case, my average volume of acid is what? Is this plus this divided by 2. So quickly, I want to punch this. So it's going to be 25.50 plus 25.55 divided by 2. So this would give me 25.53. Your answer should always be in how many place of decimal? 2 place of decimal. 2 place of decimal. Now, a quick question before we move on. From this table, I'm going to do a quick one. I'm going to do a quick one from this table now. I'm going to do a quick table. So let's have 13.45. We have 13.50. We have, let's say, 12.95. So we have this. Let's see. Let's say I have this is 0.05. This is 0.00. Let's say this is 0.00. Then this is 0.05. Let's say this is what we have. Giving you hints already. Let me change the question. So let's say I have So I have 11.45. This is B. Let's say I have 13.50. And then I have 0.05. So find A, B, and C. Now the question you're going to answer is find A, B, and C. That's question 1. Question 2, find VA, that's the average volume of acid used. I just guessed these values. Let's hope that it gives us concordant values. So I'm giving you 30 seconds to attempt this. 30 seconds. Make sure you are solving. Make sure you are solving. Somebody is already solving. Israel is already doing it. Israel say A is 0.00. So we're going to see. Okay. God's will say A is 0.00. B 1.5. Okay. Make sure you are with your calculator. Don't stay idle. Tomorrow, you are going to see what calculation is. Don't stay idle. Don't stay idle. Don't stay idle. All right. Okay. Somebody has given me the answer for C. That's what I want to see. Nwokike said 13.4. Okay. Remember, you have two questions today. You have to also find the average volume of acid. So I believe that you know that. C, 13.4. Okay. You also need to find the average volume of what? Acid. So I'm waiting. B is 1.5. Chidebube, I'm waiting. Okay. Nobody has gotten the average volume of acid yet. That's what I want to see. That's what I want to see. Average volume of acid. Israel, say 13.45. Justice, say 13.45. Okay, I think I need to solve at this point. Thank you. Now I need to solve. I'm managing my space. Now, we want to find A, and then find B, and then find C. So, what do we do to find A? Remember that the general formula is difference is equal to final minus initial. This is the general formula. So you ask yourself, which one are you looking for? In this case, I'm looking for initial. I'm looking for what? Initial. So I would make initial the subject. So if I bring it, I have that initial is final minus difference. So what is the final? The final is 13.5. My difference is 13.5. So if you do this, it is 0. So everybody knows this. So it means that A is equal to 0. Again, I'm rubbing this because I believe that you know it, right? Yes. Again, we want to get B. So for B, we are still looking for the initial. So it means initial is still final minus difference. What is our final? Our final is 12.95. Our difference is 11.45. So if you do this, what will it give you? 12.95 minus 11.45. This would give us 1.5. So it means that B is 1.5. I think most of you got it. Then quickly, I want to find C. I'm still going to rub this because I believe it is very clear and simple. So to find C, again, I hope I'm not too fast. To find C, I'm giving you time now to look at it. Some people might say this man is fast. Okay, I can move on. Thank you. So to find C, you notice that C is the difference in this case. So this is the formula, the difference. So my final is what? 13.45 minus my initial, which is what? 0.05. So if I do this subtraction, it will give me 13.45 minus 0.05. What would this give me? 13.4. 13.40. 13.40. So I've been able to fill this table. So the next thing we want to find now is to find the average volume of acid that is used. The average volume of acid that is used is going to be gotten. The average volume of acid is going to be gotten by taking the average of the concordant values. So if you check, I believe it's these two that are concordant. This is very far, obviously. So if you do this minus this, you'd see that the difference is 0.1. So you have 13.40 plus 13.50 divided by what now? Divided by 2. So if you run this calculation, you get your answer, right? So, and let me quickly divide it. 13.40, 13.4 plus 13.5 divided by 2. So my answer is 13.45. 13.45. Now, I believe this is very clear to you. Now, another thing you should understand is when you have calculated the average volume of acid used, They can ask you to find the unknown concentration. Now, for every titration analysis you want to do, you need to always balance the equation. You need to always do what? Balance the equation. So let us look at the formula for finding concentration. The formula for finding concentration. Formula, we're still going to solve a lot of calculations because I'm almost done with this. To solve calculations, we move to solve analysis, explain it, answer some problems, and then we'll be done with the revision. Now, you recall that you have C1 V1 over what? C2 V2 equals what? N1 over N2. So this is the formula. Some people can write it as C1 V1 over N1 equals what? C2 V2 over what? N2. Some people can write it this way. Both of them are what? The same, but I prefer to use this. Both of them are the same. Or some people can say CA VA, CB VB, still the same thing. Some people can even use M. Can say MA or M1 V1 over N2 V2 equals N1 N2 is the same thing. So why am I doing all this? There are people that really have forgotten some of these things. So all of them are the same. M is the same thing as C, right? So you should know this. What does C1 mean? C1 represents the concentration of the acid. The 1 means acid, the 2s stand for base. So C1 is concentration of acid, volume of acid, concentration of base, volume of base. This is the number of mole of the acid, the stoichiometric number of mole of the acid, stoichiometric number of mole of the base. When we say stoichiometric, it means that these values will be gotten from the balanced equation. To be gotten from the balanced equation. Now, if you have something like HCl plus sodium hydroxide, if these two things, remember, whenever acid reacts with a base, the product would always be salt and what? Water. Salt and water. Now, whenever you have an acid, of course, a strong acid, whenever you have an acid like this, organic and inorganic acids, where you have only one hydrogen, it means that that acid is what? Monobasic. That acid is what? Basic. I hope that is clear. So, now if these two things react, what will you get? You would have sodium combining with Cl, then you have H combining with OH. When sodium combines with Cl, you have sodium chloride, plus when H and another H becomes H2O. So this is what you have. Now, because, let us look at balancing this. So how many H do we have on this side? We have 1, 2. On our left hand side, we have 2H. On our right hand side, we have 2H. H is balanced. On this side, we have only 1 O. On this side, we have only 1 O. It is balanced. We have 1 sodium, 1 sodium, 1 chlorine or chloride, 1 chloride. So this equation is what? Balanced. Now, what is the coefficient of your acid? The coefficient of your acid is 1. So it means that N1 is equal to 1. What's the coefficient of your base? The coefficient here is 1. Once there is no number, it means it is 1. So it means that N2 in this case is what? 1. Right? Yes. What if you have H2SO4? What if you have this reacting with sodium hydroxide? So I want you to tell me N1 and N2. I'm not going to complete this. Tell me N1 and N2. I'm giving you 30 seconds. Write it in your book. Balance it. Tell me N1. Tell me N2. Let me know that you're following. Let me check the comments. Don't relent. You must walk. Don't relent. You must do what? You must walk. Don't relent. You must walk. All right? So who has the answer? Okay, N1 is 2. N1, okay, by Uche. N1 is 2, okay. Chiaku say N1 is 1. And then N2 is 2. So you see why you need to attempt it. You're getting different answers. Now, Mesoma say N1 is 1 and N2 is 2. Israel say N2 is 2. So you see why this is important, right? So, very important. Now let me solve it. So, remember this is a monobasic acid because the H is 2 here. So let us balance. What would actually happen here is that sodium would combine with this SO4. Sodium will combine with that and you have NaSO4. But this is not the correct thing because SO4 sulfate usually have a power of 2. So that power of 2, just to help some of you. When you combine sodium and SO, like sulfate ion, sodium has a power of 1, this has a power of 2, this 2 will come under here. This one will multiply, stay the same thing. So you have Na2SO4, that's what you would have. Then plus what now? You have hydrogen coming to meet this hydrogen. So of course for water it has to be just H2 and O. So it means you need to balance out now. So balancing out, let us check. You have 2 hydrogen here. You have 3. This is 2 plus 1, which is 3. In this case, you have just 2. So what you quickly do, remember I taught you that whenever you're balancing equation, for my idea is that I'll look out for an odd number and I'll change that odd number to even by putting 2, by introducing 2. So this O for me is even. So if I put 2 here, this O becomes what? It becomes 2. So let us see. So all I'm going to do now is that I would also see that this O on this side is how many? Is 1. So if I put 2 here, this O becomes how many now? It becomes 2. And if you check, your sodium here is 2, right? Yes, that is already a hint to help you. Sodium here now is how many? Is 2. So we'll see that I believe this equation is balanced. Let's check. Hydrogen here is 2 plus 2 hydrogen here, which is 4 hydrogen on the left. Then 2 times 2, 4 hydrogen on the right. SO4 is balanced. Sodium is 2, sodium is 2. O is 2 here, O is 2 here, and everybody is happy. This is balanced. Now, if you check, your N1 is for your acid. So it means that your N1 is 1. And your N2 is for your base. Your N2 is what? 2. So that is what you need to do. And I believe that is very clear to you. We're going to be taking some problems. So I've given you the formula that you can use to find unknown concentration. Then we also have what we call equation of dilution. Equation of dilution, you need to know that. Equation of dilution is just the process of reducing the concentration of a substance. It's the process of reducing the concentration of a substance. That is dilution. So you have the equation of dilution to be C1V1 equals what? C2V2. So this is the equation of dilution. Let's say you have a substance whose concentration is C1 and the volume of that substance is, let's say, V1. So they want you to dilute it to a new concentration, C2. If you want to dilute, what do? You add water to that substance, right? Of course, you don't add water if it is acid, you add acid to the water. So, but what I'm just saying is that you add water to that substance. When you add water to the substance so that you can reduce the concentration, what do you think will happen? The volume will increase, right? So your final volume V2 will increase once you add water. So it means that in order for you to dilute, you need to add water, you need water. So they can also ask you, what is the volume of water that was added? The volume of water is going to be V2 minus V1. This is how you can get the volume of water that was added. Now let's take some calculation problems and then move on. I hope you screenshot this or written it down. So let's take some problems. Of course, I'll still ask for you, but these ones are not too prevalent. Percentage purity. Percentage purity is what now? Mass or mass conc of pure substance over mass of what? Impure substance times 100. This is what you call percentage purity. Mass or mass concentration of pure substance over mass or mass concentration of impure substance. Now, there's something some students don't understand very clearly. I hope you know that impure substance and impurity are not the same. Impure substance and impurity, are they the same? No. Now, for example, if I want to drink tea. It means that if I want to drink tea, I need to add sugar to my tea, not salt, right? So it means if I want to drink tea, what I actually need for my tea is sugar and not salt, right? Yes. Now, if I now bring my sugar and I notice that in that sugar, I have some small traces of salt in that sugar. At this particular point, remember my need is sugar. So it means that my sugar that I have brought that is contaminated with small salt, that sugar is what? Is impure. That sugar is what? Impure. Now, what is the impurity in that sugar? The impurity is the salt. The impurity is the what? Salt. Why the sugar is what? The impure substance. The sugar is the what? Impure substance. The impurity is the what? Salt. I hope you understand what I've explained. Now, you want to cook food. What you need is salt, right? You don't need sugar. And you bring your salt to put it in your food. You now notice there's small sugar in that your salt. You would now say that your salt is what? Impure. Your salt is impure. If your salt is impure, what is the impurity? The impurity is sugar. I hope it is clear to you. So when they say mass of impure substance, it is the mass of everything. So for example, I'm not solving problem yet, but let me see help you understand. Say they give you, let's say 5 grams of impure substance AB. 5 grams of impure substance AB is present. Let me just frame it. Is present. If the pure substance A has a mass of, let's say, 2 grams. Now, what is number 1? Okay, let's solve. What is the percentage purity? What is the percentage purity? Number 2, what is the mass of impurity? What is the mass of impurity? Now, I just framed this to help you understand. I am giving you 30 seconds to solve this. 30 seconds because we're in the phase of solving problems now. 30 seconds, I have a past question. Now, there's a book I wrote again for Chem 107, which, of course, I don't have it available for sale because it has finished. Now, you can see it's this prime concept, this one. So I have it, and I have a lot of exam past questions in it. So what I'm going to do, I'm going to also snap some of these past questions and send it to this particular and upload it as a link on this video. So do well to hit the subscribe button. Now, again, by the time this video has ended, I would like you to drop comments on this video. Anybody whose comment gets the most likes, I'm going to give you a bonus tip on the group. I'll be giving you some money on the group, on our WhatsApp group. When we end the video, drop a comment. All of you should drop a comment. The person whose comment gets the most likes, I'm going to give you something. I won't tell you the amount, but it is huge. That can sustain you for some time. I'm going to drop something for you. So I'm allowing you to solve this problem. Who has the answer? Who has the answer? Oh, thank you. God's will. Thank you. Zikora, 40% and 3 grams. Okay, I think I should solve it at this point. Okay, a lot of people have provided their answers. So let me solve now. So I will manage my space because I use the whole board to write the question. So what do I have? They said 5 grams of impure substance. So it means the mass of impure substance is 5 grams. Let me solve from here. The mass of impure substance is 5 grams, is present. If the pure substance A has a mass of 2 grams, so mass of pure substance is 2 grams. Mass of pure is 2 grams over mass of impure substance, which is 5 times what? 100. So if I solve this, what is the percentage purity? That is the first question. 2 divided by 5 times 100, that is 40%. So it means most of you got it. You are very intelligent, and trust me, you will do very well tomorrow. So that is the percentage purity, 40%. They say, what is the mass of impurity? The mass of impurity is going to be mass of impure substance minus mass of pure substance. So that is the mass of impurity. So which is going to be 5 minus 2, which is 3 grams. So if they ask you again, they can ask you, what is the percentage impurity? What is the percentage what? Impurity. It's not common, but they still ask it. It's still obtainable. What is the percentage impurity? Of course, if you want to find percentage impurity now, it's now going to be mass of impurity over mass of impure substance. So percentage impurity is going to be 3 over 5 times 100. Or you can just say 100% minus 40, which is 60%. So you just say 100 minus percentage purity, which is 60%. Or you can say 3 over 5 times 100. It will give you the same thing. So I believe it's clear. If you are okay, say move on. Let's move on. If you are okay with this, say move on quickly. Say move on. If you are okay. Thank you. Uchechi said 60%. The 60% you said, Uchechi, is it impurity? 60% for impurity. Thank you. Thank you. Creative videos. Thank you. I appreciate your kind words. Thank you. Now move on. I want to take some more problems. So remember, for those that are joining us late, Chem 107 is majorly calculation from every corners. Majorly. Don't say I did not tell you. If you're studying this night and there are things you feel like you cannot understand, leave them, go to calculation. I'm not saying other areas will not come. We're still going to touch some things under salt analysis that you need to know, but don't forget, it is majorly calculation. Let me still give you another thing I just remembered, which is conversion. You've seen it very well. Now, you need to know that 1 dm cube is same thing as 1 liter. 1 dm cube is same thing as what? 1 liter. So dm cube and liter are the same. Never you forget that. So if they tell you 20 dm cube, it means they're actually telling you what? 20 liters. If they tell you 20 liters, they are telling you dm cube. So dm cube and liters are what? The same. Don't forget. Another thing you should not forget is that cm cube, 1 cm cube is same thing as 1 milliliter. So cm cube and milliliter are what? The same. If somebody gives you, let's say 50 ml, 50 milliliter, they are just also telling you 50 cm cube. They are what? The same. So that allows these ones confuse you in exam. They are what? The same. Now, what do you need to know? You need to know their conversion. So what is the conversion? 1000 cm cube is equal to 1 dm cube. This is what you need to know. I'll give you one example. What is the example? Convert 15 cm cube to dm cube. Quickly, drop the answer quickly. Be active. Drop the answer. Convert 15 cm cube to dm cube. Drop the answer. Who has the answer? Drop the answer. Drop the answer. Thank you, God's will. Thank you. Very, very fast. I love that. God's will, very fast. Now let me solve it. So convert 15 cm cube to dm cube. You know that 1000 cm cube is this. So you can use this formula, or you can simply say anytime you want to convert from cm cube to dm cube, divide by 1000. Anytime you want to convert from cm cube to dm cube, divide by what? 1000. So I have 15 divided by 1000. It will give me 0.0015, which is 1, 2, 3. 1, 2, 3, right? 1, 2, 3. So this is 0.015, I think. 1, 2, 3. So 0.015 dm cube. 0.015 dm cube. Anytime you are converting from cm cube to dm cube, divide by 1000. If you are converting from dm cube to cm cube, multiply by 1000. Never you forget that. Thank you. Now let's take this problem. Now, see this question. I'll read it. I don't know. This is not calculation. Let me read it. So, a student was required to determine, please listen to the question. A student was required to determine the number of moles per liter of sodium hydroxide solution using HCl solution that contained, hey, let me write it. Because reading it, some of you will not be able to sustain this. A student was required to determine the number of moles per liter of sodium hydroxide solution using HCl solution that contains 1 mole per liter, which is the standard solution. They gave options. I had to just twerk the question to which is the standard solution. So they said which of the following is true. That's how they asked it. So I want you to read this, digest it, so I can now give you, we can now answer it. So read it and tell me which one you think. Quickly, drop it in the comments. Drop it. I want to write another question. Drop the answer while I'm writing the next question. So we have this. Okay. So we have, how can one prepare 750 ml solution of 0.5 molar H2SO4 from 2.5 molar H2SO4 stock solution. So we have two questions now. For the first one, I'll answer it. I'll allow you to solve the second one. I will answer. I'm waiting. I'm waiting. HCl, everybody says that is correct. So for this first question, it said a student was required to determine the number of moles per day. So you want to calculate the molarity for sodium hydroxide. It said HCl solution that contains, so they gave you the mole of HCl, so you want to calculate that for sodium hydroxide. So the standard is the one whose concentration is known, which is HCl. So this is very simple. I need you to analyze it, then we'll solve. So while you're analyzing that, I'll put another question. By the time I'm finishing this question, I'll come and solve this. So that is what I'll do to save time. So I'll put another question there. So we have calculate the mole of sodium carbonate in 250 cm cube of n over 10 solution. So who has the answer? I will solve this now, then I'll give you time again to solve this. So that's what I'll do. Then we'll solve about 5 calculations, then we'll move to the next. So who has the answer to this? Let's check. Let's check. Any answer? Nobody has gotten the answer. I'm going to solve the second question now. Okay, God's will said 150 mil. Okay, 15. Okay, let me solve it. So just ignore this one. Let us solve this together. Now, they said, how can one prepare 750 mil? Remember, this mil is same thing as cm cube, so it means this is volume. So how can you prepare a 750 volume solution? So it means that this is what you want to prepare. This is your final volume, V2. So V2 is 750 mil. That is what you want to prepare. Solution of this concentration, that is to say C2, your final concentration is 0.5. From, remember, from is where you are starting, which is V1, from 2.5. So it means we don't know V1, but we know C1, which is 2.5. So it quickly tells you that this is a question under equation of dilution. It's a question under equation of what? Dilution. And what is the concept? C1V1 equals C2V2. That is the idea. So I'm looking for C1. I'll simply say that C1 is going to be C2V2 over V1. So what is C2? C2 is 0.5. What is V2? 750. What is V1? Okay, we're looking for V1, so over C1. So what is our C1? 2.5. So quickly, if I punch this, now somebody may ask, don't we need to convert? You don't need to convert your volume. Because if this is 7 mil, it means that your V1 is also going to be in mil. So you don't need to convert except your options are saying otherwise. 0.5 times 750 divided by 2.5. So what do we have? This is 150 mil. Remember, this is 150 mil or 150 cm cube. That is the answer. So I believe it's very clear. Now they can also ask you, what is the volume of water that was used in this dilution? What is the volume, or what volume of water was used in diluting the solution? Somebody should drop the answer. What volume of water was used in diluting that solution? Okay, Lone Wolf, thank you for converting to dm cube. When you convert to dm cube, I don't think you get 0.15. Abi, is that what you will get? 150 divided by 1000. Okay, 0.15. Thank you, Lone Wolf. Okay. Everybody. Okay, 600 mil. Everybody got it. So how did you get 600 mil? Very simple. If they ask you what volume of water was used in diluting, it means you're going to say 750 minus 150, which is 600. Very clear. Now let's solve question together. So let's solve this together. I still have more calculations to give you before we go to salt analysis and summarize them. So they said calculate the mole of sodium carbonate. So we're looking for the mole of sodium carbonate. I should allow you solve this, then I'll drop the next question. Calculate the mole. What do you think? What do you think? What do you think? I should allow you solve this while I drop the next question. Tell me, tell me, tell me. So I should solve. Hey, I hope you want to work. Okay, people have gotten the answer. I should allow you solve it while I drop the next. I have another question which says, what volume of 0.3 molar H2SO4 will be required to neutralize CM cube of 0.200 molar sodium hydroxide solution. So now I'm going to solve. Let me check your answers for this. I'm going to solve this, then I'll allow you to solve this again. That's how we'll be doing. We'll still have about 4 more calculations to do so that we can now move out of this. So who else? Somebody says 0. Somebody said Zikora says 0.025. Godswill says 0.025. Aja says 0.0125. Okay, let me solve it. Valentine says 0.4. Justice says 0.025. Okay, let me solve now. Remember, we want to do this one. We want to solve this together. When I finish, I'll allow you to solve this. So focus on this part now. So they said, calculate the mole of sodium carbonate. The mole. So we're looking for the number of mole. This is what we're looking for. They gave us volume of 250 cm cube. They gave us concentration. Remember, the concentration is 1/10. Is 1/10, which is, I think, is 0.1 molar or mole per dm cube. That is what the concentration is. So they gave us these things. They want us to find number of mole. I'm going to use the idea of N equals what? CV over 1000. This is the idea. Remember, in this case, your volume must be in cm cube. N is CV over 1000. So what is our C? 0.1. What is our V? 250 divided by 1000. I don't expect anybody to be failing this kind of question. So 0.1 times 250 divided by 1000. It would give us 0.025 mole. So I believe it's clear. Some persons got it, and I believe it's clear. So I don't understand. Okay, some people already started attempting the second question. So I love that. I love that. So attempt the second question now while I'll drop the first one. Remember, you are yet to subscribe. Hit the subscribe button. I would need you to get our channel to 5,000 subscribers. Is it possible? Yes. In UNL, we have over 7,000 science students. So keep sharing this video. Tell your friends to subscribe. Remember the promise. Once we finish this live session, drop a comment. If your comment gets the most like, I'm going to check it and I'll ask for that person on our WhatsApp group, and I'm going to transfer you huge amount of money that would encourage you for supporting this. So let's see who has more followers on this. So I'm going to Rob. I will allow you to solve this. Let me drop another question before I solve that one. Now I have so the approximate concentration of solution formed when 6 grams of potassium hydroxide is dissolved in 200 cm cube of water is, so they want you to solve this. Potassium K is 39 atomic mass, oxygen is 16, hydrogen is 1. So let's solve this one together now. Now let's solve this, then I will allow you to do this. So focus and learn what we're solving here. And this question says, what volume? We are looking for volume. What volume of this? So we're trying to find, let me call it V1. What volume? So we're trying to find V1. What volume of 0.300 molar H2SO4? So it means the concentration C1 is 0.300. Will be required to neutralize 25 cm cube. So it means V2 is 25 cm cube. To neutralize 25 cm cube of this, so C2 is 0.200 molar of sodium hydroxide. So this is what you have. Remember, solving this thing directly. You have H2SO4 and sodium hydroxide. You need to balance the equation. I think we'll balance something like this today. If you balance it, you have H2SO4 plus sodium hydroxide to give you sodium sulfate plus 2 water. So you have this. I think this is what we did, where we discovered that N1 is 1. We discovered that N1 is 1, N2 is what? 2. So using our formula, C1 V1 over C2 V2 equals N1 over N2. We'll be able to solve this, right? I don't have space, so I will rub the question. So I'll rub the question. Now, using this, I'm trying to find V1. So let's substitute. Or let me just make V1 the subject. So V1 is going to be C2 V2 N1 over C1 N2. So this is what you have. So what is my C2? My C2 is 0.2. My V2 is 25. My N1 is 1. My C1 is 0.3. And then my N2 is 2. So if I punch this, let's see what it would give us. 0.2 times 25 divided by 0.3 divided by 2. So this would give me 8.33 cm cubed. Let's see who got it. Nobody got it. Nobody got it. Except I didn't punch well. Nobody got it. This is quite okay. Ude Bunam got it. Thank you. Glory got it. Thank you. God's will got it. All right. So quickly attempt the next question. Now I want you to attempt this. So upon copying this one, attempt this. I will drop another question. So I think I can rub at this point. I want to drop another question. So I think this should be the last calculation I will drop. Should be the last calculation. So I would solve this before I drop that question. So let me see your answers. So while you're solving, let me fill my marker. Okay, 1.1, 1.1, okay. Aja say 1.1, Obutaku said 1.1. Okay, let's see. Okay, I think it's time for me to solve. All right. So we have said the approximate concentration of solution formed. So we're looking for concentration of solution formed when 6 grams. So the mass is 6 grams. When 6 grams of potassium hydroxide dissolves in 200 cm cube of water. So the volume is 200 cm cube. We are looking for the concentration, right? Now we need to find out the molar mass of potassium hydroxide, KOH. Potassium hydroxide is 39 plus 16 plus 1, which is going to give us this 40, I think 56 grams. So I've gotten the molar mass. So using one formula to kill the bed, we have concentration is mass times 1000 over molar mass times volume. So this formula can help us. Remember, I'm trying to find concentration. So my mass is 6 times 1000 divided by my molar mass, 56, times my volume, 200. So if I punch this, let's see who got it. I would have 6000 divided by 56 divided by 200. So this is going to give me 0.54 mole per dm cube. So let's see who got it. Okay, thank you. Lord something got it. Lord Gamma. Okay, Elvin got it. Oswil got it. Adebe got it. Victoria got it. All right, let me give you one more calculation to solve. So you have let's do this one. And before that calculation, answer this question. The indicator that is blue in alkaline solution is what is the answer? I have option A, bromophenol blue, option B, bromothymol blue, option C, phenolphthalein, D, methyl orange. You'll be seeing this kind of problems. So you'll be seeing all those kind of problems. So let's run this calculation now. The answer is bromothymol blue. So now we have this. A dibasic acid H2X was titrated with 25 cm cube portion of solution containing 1.00 gram of sodium hydroxide in 250 cm cube solution, if the average volume of H2X used is 24.8 cm cube, calculate the concentration of sodium hydroxide in mole per dm cube. II, what is the concentration of H2X in mole per dm cube? So I find the molar mass of H2X. Find the molar mass of H2X. Given that 100 cm cube of solution H2X contained 0.485 grams of the acid. So I'm going to give you 2 minutes to attempt this. So, and remember, I will need to rub the boards to be able to solve fully. So first thing, screenshot this. Then I'm giving you 2 minutes to attempt this. Then I'm going to solve. Attempt it. Just try solving it. This is a live session. So try solving it. Then I'll give you 2 minutes or less than 2 minutes and we can solve together. Let me see your comments. Okay. So I would allow you to attempt it now. 2 minutes. Who has the answer? Waiting. Be fast. You have 1 minute left. 1 minute left. Okay. Lone Wolf. Thank you. Lone Wolf is pulling weight. Give us 3 answers. Okay. We need to solve together now so that we can go to salt analysis and summarize. Okay. Aja said 1 dm cube. Okay. Remember, if you are yet to subscribe and you are present, please do well to hit the subscribe button. Okay. Glory. All right, I think I should solve now. Now let's do it together and save time. As I said, a dibasic acid. Just stop. I'll need you to stop solving. Let's do it. This is the last calculation we're going to take. So stop solving. Let's do it together. A dibasic acid, H2S. So why did they say it is dibasic? Because your H has 2. That's why it is dibasic. If H is just only H, then it is monobasic. So a dibasic acid, H2X. X means you don't know the acid. It is an unknown acid. Was titrated with 25 cm³ portion of solution. Now, of course, the acid was titrated against a volume of a base, which is 25 cm³. So let us say volume V2 as the volume of base is 25 cm³. 25 cm³ portion of solution. Solution containing 1 grams of sodium hydroxide in 250 cm³. So instead of giving us the concentration of the base, they want us to find it. And that is the first question. The first question says, calculate the concentration of sodium hydroxide in mole per dm³. What information did they give you? They gave you the mass as 1 gram, and this 1 gram is present at 250 cm³. Now, for you to calculate the concentration, which is C2, you need to use the formula I gave you. And what is that formula? Mass times 1000 over what? Molar mass times what? The given volume. So with this, you'll be able to calculate the concentration. So what do we have? We have to find the molar mass of sodium hydroxide. It's 40, I think. We don't even need to do that. 23 plus 16 plus 1. So this is going to be 40. 24, so it's 40. So I have my mass given to me is 1 gram. So my mass is 1 times 1000 divided by molar mass is 40 times given volume. So with this, I have answered the first question, the concentration. So what would the answer be? 1000 divided by 40 divided by 250. So it is C2 is 0.1 molarity or mole per dm³. I've answered the first question. I don't know who got it, but I didn't see this answer in your options. So we've gotten the first question, the concentration of sodium hydroxide. Now we know V2, we know C2. Now let's read again. It said a dibasic acid was titrated with 25 cm³ portion of the base in this of 250 cm³ solution. Now if the average volume of the acid is this, so they gave us V1 to be 24.8 cm³. So these are the things they gave us. Now the second part of the question says, what is the concentration of that acid in mole per dm³? They want us to find C1. So first thing you want to do is to balance your equation. Now you don't even need to balance equation under exam condition. Since your acid is dibasic and your sodium is this, so what do you think you would have? You're going to have your number of mole N1. This is going to be 1 for the acid. Since H is 2, then your acid N1 will be 1, then N2 will be 2. That is what it is. So anytime you have this as 2 and you're dealing with sodium hydroxide, then this is what you expect. N1 is 1, N2 is 2. Don't forget. So using our formula, C1V1 over C2V2 equals N1 over N2. So what do you think this would give us? We're trying to find C1. So C1 is going to be C2V2N1 over V1N2. So what is C2? C2 is 0.1. What is V2? It is 25. N1, 1 divided by V1. 24.8 times N2, which is 2. So if I punch this, let's see what we have. We have 0.1 times 25 divided by 24.8 divided by 2. So I have 0.05 molarity. So that is my C1. I don't know if anybody got it. I didn't see these answers in the option in your comments. So I don't know if any of you got Okay. Somebody got the first one. Okay. Okay. Thank you. Now I want to rub this short so that I can rub it and then solve the last question, the number 3 part of that question. Somebody said VB is 25. Yes, that is VB 25. That's what we used. That's what I used. So if I can rub, say move on, say move on, say move on, so that we can solve the last part. Move on. If you are done screenshotting this, say move on. Say move on. Say move on, say move on, say move on. Thank you, move on. So I have to rub this side. Okay, let me rub this part. So we want to find the last question. They say find the molar mass of H2X. Given that 100 cm cube of the solution H2X contained this mass of acid. So now, still using this formula, we're going to solve. Now, they gave us mass, they gave us volume, so and we know the concentration. Remember, the acid is C1 equals mass times 1000 divided by molar mass of the acid times what? Volume. We want to find molar mass. We know concentration C1 already. So I want to find molar mass. I'll make molar mass the solver. What do I do? Just take molar mass here, bring C1 there. That is it. So molar mass equals mass times 1000 divided by C1 times volume. So what is mass? The mass they gave us is 0.485 times 1000 divided by C1 we got 0.05 approximately times the volume they gave us is 100. So using this, you can see how direct it is. Very straightforward. So I have 0.485 times 1000 divided by 0.05 divided by 100. So I have approximately 97. Remember, we did a lot of approximation here. I believe this would have given us 98. So we have approximately 97 grams. So, but in reality, it's supposed to be 98, which is H2SO4, 98 grams. So I believe it is clear. So I needed to screenshot. We want to move to salt analysis now. That's the final part. Salt analysis. If you are ready to move to salt analysis, say move on. Say move on. Say move on. If you are done and you are good to move, say move on to salt analysis. Okay, everybody saying move on. So it means you're ready and good to go. Yes. So remember, we're going to be doing a good summary on our salt analysis part. The major parts exam will be asking you. There are certain things you don't need to stress yourself in knowing. So you have your qualitative analysis. So you have your qualitative analysis. What is qualitative analysis? It is the method of finding. It is a method that is used to find what? The ions that are present in a substance, usually a salt. So it's a method that are used in finding the the ions that are present in a substance, usually a salt. Now, I need you to know that ions are charged what? Particles. Ions are what? Charged particles. If it's a single particle that has a charge, it is called an ion. But if it is a group of atoms, the standard name is what? Radical. So if I have something like this, Cl minus, this is an ion. If I have something like this, NO3 minus, it's still an ion. But because this is a group, you have N, you have O, this is a group of atoms. The standard name for this is what? Radical. But they are both ions. I hope you understand what ions are. Ions are charged what? Particles. Particles that carry either positive or negative charge are what we call ions. So, ions generally can be classified into two. So, you have two types of ions. One of them is what you call anions. You have your anions. Another name for anion is what you call acid radicals. Anions can also be called what? Acid radicals. And what are anions? Anions are negatively charged. Anions are what? Negatively charged. Anions are what? Negatively charged. So don't forget that. And the second type of ions are what you call cations. Cations. Another name for cations is what? Metallic ions. Metallic ions. That's another name for cations. And what are cations? They are positively charged ions. So these are the two group or categories of ions you need to know. Your anions, which are known as acid radicals. Why do you call them acid radicals? Because those ions are the ions that actually makes acids to the acids. They are the ions that are connected to hydrogen. So that's why you call them acid radicals. For example, you have HCl. So you can see that this Cl is an anion. So, and this is already an acid. That's why you call this acid radical. That's why you can call them acid radicals. Why these ones? You call them metallic ions because they are all metals. Most of them are metals, even though all are not metals. Most of them are metals. So, those are the two categories of ions. So let us list examples of anions that we would be meeting in our Chem 101 exams. The anions we would be meeting would include chloride. This chloride. Remember, if you have Cl, there is no charge. This is chlorine. This chlorine atom. So the moment you put a charge, you end the name. Anytime there is a charge for single particles like this, you end the name with IDE. So if it becomes chloride ion, IDE. So you have your chloride, you have your bromide, you have your iodide. These are the three. And these three ions are usually called halides. They are usually called what? Halides. So if they tell you halides, it means they are talking about chloride, bromide, and what? Iodide, right? But if you are talking about just their atoms, you call them halogens. But take note of what we're talking about, halides. Now, you also have carbonate. This carbonate, don't forget. You also have sulfate. This is sulfate. Let me write it here. SO4 2 minus is what? Sulfate. And some people spell it this way. Anyone is okay. Sulfate. So this is sulfate. Then you have SO3 2 minus. This one is called what? SO3 2 minus is called sulfite. ITE. Don't mix them. This one is called sulfite. The name ends in what? ITE. So they are not the same. I will still give you one distinguishing factor between these two things that exam would usually ask you. I'll still tell you. This sulfite. Then you have S2 minus. This is what now? S2 minus. This is what? Sulfide. IDE. Because it's a single element that has a charge. The name should end with IDE. Sulfide. Then you have NO3 minus. This is nitrate, nitrate. You have this. So these are basically the ions that you will need to know, the anions that you will need to know for your Chem 107 exams. So don't forget these anions. Then for your cations, you have so many of them. So, but I'm still going to list cation in a different table. We are going to classify cation into 6 groups, which we are going to learn. And I'm going to give you shortcuts for remembering which group, which cation falls. I'm going to give you mnemonics. That is what we're going to be dealing with in this part. So let me just give you simple examples. You have your calcium, you have your barium, you have your iron 3, you have your iron 2, and so on. You have your mercury, you have your silver. So these are examples of your ions you need to know. Remember, qualitative analysis is a process of finding out which of these ions are present in your what substance. Now for your Chem 107, they would usually mix for you 2 salts. They would usually mix what? 2 salts. It means that if you have a mixture of 2 salts, 2 simple salts, you are expected to get how many anions? 2 anions. And you're expected to have how many cations? 2 cations. You are very correct. If you have a mixture of 3 salts, how many anions do you expect to find? You expect 3 anions. You are very correct. And how many cations? 3 cations. You are very correct. So take note of these things. If you have just a single salt, how many anions? 1 anion. How many cation? 1 cation. So take note of this. Now, if you go to the lab, remember your exam is going to be asking you some of these lab things. Follow me as I explain to you. Now, when you go to the lab, you want to find out which ions are present in your salt sample. You're going to carry out the test in this order. You have 3 tests or 3 stages of test to carry out where you want to find out which ions are present. How many stages of test do you have? 3 stages. Number 1 thing you need to do is what you call preliminary test. Preliminary what? Test. That is number 1 of the 3 stages you need to carry out. Number 2 is what you call tests for anion. Test for what? Anion or acid radical. Number 3 is what you call test now for what? Cation. So these are the 3 stages of test you need to follow when you get to the lab. Exam will ask you. One of the following is not required in qualitative analysis. They will add a 4th one. So don't forget that. Now, in preliminary test is a basic test where you don't need any reaction to do anything. So preliminary test, number 1, preliminary would involve, number 1, color identification. Color identification is a preliminary test. So if they give you your salt and you look at it and you say, okay, this salt is green. If you have a green salt, what are the things that should come to your mind? You'll be looking at calcium chloride. You'll be looking at salt of chromium. You'll be looking at salt of iron 2. Take note of these things I'm saying. I'm going to still give you some notes. Maybe I'll snap it and still send to you to help you to still study, right? So that is color identification, which is preliminary test. Exam can also ask you which of the following tests does not fall under the preliminary. So you should know color identification is preliminary. Texture is preliminary. When you say texture, is it granular? Is your salt granular? Is it powdered? Is it crystalline? Is it crystal? So this is what you call texture. Is under preliminary. You also have what you call your flame test. You also have what you call what? Flame test. This is also preliminary. Now take note. Color can give you, the color of the salt can suggest for you the cation that is there. The color can suggest for you the cation. The flame test can also suggest for you the what? The cation that is there. Now, you have your color, you have your texture, you have your flame test. You also have what you call solubility. Find out whether it is soluble in water. Now, before we move out of preliminary, we're going to talk about two things here. We're going to talk about flame test. We're going to talk about solubility of salts in water. So you see the sequence with which we'll be learning these things. If you are following what we're doing, I need to check the comments. If you are following what I'm doing, say move on, it is clear. Say move on, it is clear. Some people have dropped. If you are still following me, say move on, it is clear. Say move on, it is clear, so that I'll know you are not tired yet. If you are tired, tell me. Okay, move on, thank you. Now, remember we're still dealing with preliminary tests. So color, texture, flame test, and solubility. Let me just give you a quick one under color. Under color, when you have green, this is one that is very specific. If your salt is green, you're expecting calcium chloride, you're expecting salt of chromium, you're expecting iron 2. If you have what? Green, that is for color. You'll be expecting these things. You can have brown. If you have brown or reddish brown, you'll be talking of salt of iron what? 3. Salt of iron what? 3 for color. So take note of these things for your color. And there are still more colors, but these are the prevalent colors that you need to know. Give me 1 second. Let's live session now. I thought I told you. I'm on live now. I'm not done. So sorry, I had a call. Sorry. Now, so you have color and so on. Now, let us look at flame test. I have made this flame test in a way that will be easy for us to remember, because I don't want you to cram too many things. So I've looked at every of the things I'll be showing you. I try to bring shortcuts that will help you remember. So for flame test, see what I did. SSCCPB. This is what I did. So this would help me remember. SS, you shouldn't forget. SSCCPB. These are the ions. Remember, flame test is for cations. Flame test is for what? Cations. That is metallic ions. Don't forget. SSCCPB. Take note of this. SSCCPB. Take note of it. Now, for SS, see what I would ask you. Now, is it possible for you to see a yellow brick? Have you ever seen a yellow brick? You know brick blocks that they use in building house. Brick block. Have you ever seen a yellow brick? Yellow brick. Have you seen a yellow brick? I believe that your answer would be what? No. Now, what does S stand for? S stands for sodium. So it means that the flame test of sodium is yellow. The flame test S, this other S stands for strontium. So this is sodium, strontium, SS, yellow brick. Don't forget. Have you seen a yellow brick? No, it is not possible. What is possible? Red brick. So SS, so sodium, strontium, yellow brick. Don't forget. Then you have your CC. You have your CC. You have your what? CC. Have you ever seen a blue? Have you ever seen a blue? And what do we have? So this is C for copper and calcium. So have you ever seen a blue blood? So this is also what you used to remember. Have you ever seen a blue blood? No, bloods are usually what? Red. So you have copper is blue, calcium is blood red. Blood are usually what? Red. Have you seen a blue blood? No. Have you seen a yellow brick? No. So remember, sodium, strontium, copper, calcium. Sodium, strontium, copper, calcium. I hope this is very clear to you. So don't forget, these are the flame colors. Then the last one is Pb. Pb simply means P is for potassium. Potassium. And then B is for barium. Barium. So what is Pb? Pb is violet. Don't forget this. Violet green. Violet green. Potassium is violet. You can say violent green. Have you seen a violent green before? No. So remember this. Again, sodium is yellow. Strontium is what? Brick red. You have copper is blue green. Blue. You can say blue or blue green. You have your calcium is what? Blood red. You have your potassium is violet, or you say lilac. Lilac means violet. You can talk about barium, which is what? Green, or you can say pale green. Pale means light green. If this is clear to you, say it is clear. Move on. That is flame test. If it is clear, say clear. If it is not, say re-explain it very quickly, and I'll move on. The experiment is becoming dark. I need to be fast to summarize. It's clear. Thank you. All right. So that is flame test. You need to know these things. Then the next one is solubility. 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 Now, solubility in water. Remember, I'm talking about solubility in water. So you have different salts have their solubility in water. So solubility. Number one is, I don't know if I should be writing it, but number one is all salts of sodium, potassium, and ammonium ion, all salts of sodium, potassium, ammonium, and nitrate. All salts of what? Potassium, sodium, potassium, ammonium, and what? Nitrate. Almost all their salts are what? Soluble. Almost all their salts are what? Soluble. Almost all their salts are what? Soluble. What does it mean? Exam would ask you. They would ask you that, is this substance soluble? You have sodium carbonate. Is sodium carbonate soluble? How do you know? You would say yes, sodium carbonate is soluble. Why would you say sodium carbonate is soluble? Because it contains sodium. Any salt that contains sodium or potassium or ammonium is expected to be what? Soluble in water. Remember, it is solubility in water. Now, they can ask you, is silver nitrate soluble? The answer would be soluble because it contains nitrate. Any salt that contains nitrate is expected to be what? Soluble in water. So that is one of the first you should know. Then number two, all chlorides except silver, lead, and mercury. This is the symbol of silver, lead, and mercury. All chlorides except these ones are what? Soluble. Are soluble. All chlorides except this, and this are what? Soluble. So they can ask you, is silver chloride, is it soluble? Of course it is not soluble. They can ask you, is lead sulfate soluble? Of course it is not. Sorry, we're talking about chlorides and I'm putting sulfate, even though lead sulfate is not soluble. Is lead chloride, is it soluble? The answer is no. So we say any other one is soluble except these ones. I hope that is clear to you. The weather is becoming very dark. Okay, so that is this. Then number three, all carbonates are insoluble except for sodium, potassium, and ammonium carbonate. All carbonates are what? Insoluble, except for this carbonate. So any other carbonate you talk about is insoluble. Is calcium carbonate soluble? No, it is insoluble. Is aluminum carbonate soluble? No, it is insoluble. Right? So it is only these carbonates that are soluble. So take notes of this. Then you have sulfates also. Number 4, all sulfates are soluble except for barium and lead. So the sulfate of barium and lead are what? Insoluble. They are what? Insoluble. Number 5, I want you to know is that hydroxides, let me say the solubility, this is a common exam question. The solubility of hydroxides is dependent on their pH. Hydroxides, their solubility will be dependent on their what? pH. So there's a particular pH it would have, it will be soluble. There's a particular pH it would have, it will be insoluble. So it is dependent on the pH range. So these are the things you need to know about solubility. That is under preliminary test. I believe I can rub the same move on. My God, can you still see? Say move on, my God. And I didn't remember to buy fuel in my gen. Say move on. I need to be very fast this time. So now I want to move to test for anions. Test for anions. Now, under the test for anions, we have two types of test for anions. One is what we call dry tests for anions. The second one is what we call what? Wet test for anions. So these are the two types of tests for anions. We have done preliminary. We're looking at tests for anions. Then we'll do for cations, and we call it a day. So under test for anions, we have the dry test and we have the what? Wet test. As their name imply, for dry test, you use a dry sample of the salt. Without dissolving it in any solvent. For wet test, the solution of that salt is prepared. For dry test, you use a dry sample. For wet test, a solution of that sample is what? Prepared. So don't forget that. Now, under the dry test, there are two reagents that are used in the dry test. Reagents under dry test, there are two reagents. One reagent is dilute HCl. Dilute what? HCl. And the other reagent is what? Conc H2SO4. The two reagents that are used in dry test are what? Dilute HCl. Don't just say HCl. If you say HCl, it means you can mean conc or dilute. So it is dilute HCl, don't forget, but concentrated H2SO4. These are the two reagents used in dry test. Now, under the use of dilute HCl, what anions can be obtained using dilute HCl? Take note, the anions you can obtain using dilute HCl are anions from weak acids. They are anions from what? Weak acids. They are anions from where? Weak acid. Take note of that statement. It's very important. Now think of some weak acids. So the anions you can get from here is going to be carbonate, because carbonate is in a weak acid. Say you have H2CO3. This is a weak acid. So carbonate is from a weak acid. So to get anions, the anions you get using dilute HCl are anions from weak acid. So carbonate can be gotten using dilute HCl. What else can you get? You can get sulfide. You can get sulfide using this. What else can you get? You can get sulfides. You can get sulfides using this. So these are the certain anions that you can get from here. So don't forget this. Don't forget this. Now, what about our conc H2SO4? What are the anions we can obtain using conc H2SO4? Conc H2SO4 can be used to obtain chloride. Can be used to obtain chloride. It can be used to obtain bromide. It can be used to obtain iodide. That is the halides. It can be used to obtain nitrates. Can be used to obtain what? Nitrates. So you can use it to obtain these ions. So don't forget this. Your dry test is divided into two reagents, dilute HCl and conc H2SO4. What are the the anions you can obtain from dilute HCl? Carbonate, sulfide, and what? Sulfate. I hope this is clear to you. Yes, that is under dry test. Now, when you come to wet test can be used to determine one major anion, which is what? Sulfate. So you use your wet test to determine what? Sulfate. Take note, your wet test is also used for confirmatory test. It's also used for what? Confirmation of other anions. It's used for confirmation of what? Other anions. Meanwhile, the anion you can obtain using wet test is sulfate. Screenshot this. If it is clear to you, tell me to move on. I want to rub the ball and move on quickly. Can you still see? My God, it's becoming very dark. Let me try to put on my pen, please. Give me 1 minute. All right, so I'm back. I believe it's better now. Oh my God. All right, are we still following? Thank you. Sorry for the delay. So I just turned on my gen. I don't know how much fuel I have. So if you are ready, say move on. Can I rub the board now? Can I rub the board? Can I rub the board? Say move on quickly. Move on. Say move on if you're good. Say move on. Because I can see some people still asking old questions. Say move on if you're ready. Thank you. Thank you. Hit the like button. Hit the subscribe if you are yet to subscribe. So we are talking about tests for anions, dry test, dilute HCl, and conc H2SO4. These are the anions you can obtain using dilute HCl. While for conc H2SO4, these are the anions you can obtain. While for wet test, you can obtain the sulfate ion. I want to point out some things for you. Now, in all of these ions, when you add dilute HCl to your salt, and your salt contains any of these ions, what will you observe? You would observe evolution of gases. So we are going to talk about the gases of these ions, and we are going to talk about their colors and what reactions they can have very quickly. So we have the gases, we have the color, we have odor, so and we still have their behavior to litmus. How do they behave with litmus? Of course, moist litmus. For gases, the litmus must be moist. They can ask you, why do you use moist litmus and not dry litmus when testing for gases? Because gases don't contain water. Acids usually contain water. So in order for litmus to be effective, there needs to be water. So you moist your litmus by providing water. That water gives to your litmus hydrogen ion, right? So that it can now behave that way. Now, one of the gases is CO2. CO2 gas is a gas that is usually evolved. Let me rewrite this thing this way. Let me rewrite this thing this way. The gases, the anion, the color, the odor, and moist litmus, effect on moist litmus. Right? So you need to know these things. So CO2 gas is always evolved from which anion? Carbonate. From carbonate. And what is the color of CO2? It is what? Colorless. Colorless. And it is also what? Odorless. Odorless. It doesn't have odor. CO2, that is what comes out from your Coca-Cola. When you shake your Coca-Cola and open it, you hear shh, effervescence, that is CO2. You can see that there's no color there and there's no odor there. So it is colorless and odorless. So what effect does it have on moist litmus? Let me help you again. On moist litmus, I need you to know that CO2 gas is an acidic gas. CO2 gas is what? An acidic gas. That's why. Now, you should know this. ABr and then BRB. I use this. BR. In acids, you turn blue litmus to red. BRB. In base, you turn red litmus to blue. For acids, acid turn blue litmus to red. Base turns red litmus to what? Blue. Don't forget. Remember, CO2 is an acidic gas. So it means it will turn blue litmus to what? Red. Now, the next gas is HCl. So HCl comes from which anion? It comes from the chloride anion. It comes from the what? Chloride anion. So what is the color? It is colorless, but it is not odorless. It has a what? Pungent smell. It has a what? Pungent smell. So what is the action on moist litmus? Again, it is an acid gas, like you can see, HCl gas, hydrogen chloride gas, from blue to what? To red. I hope that is clear to you. Now you also have SO2 gas. SO2 gas, what anion does it come from? This is another place exam would ask you this tomorrow, I'm sure. They will ask you, SO2 gas comes from which anion? I want you to guess. Drop it in the comment before I write it. Drop the anion where SO2 gas comes from. Drop it in the comment section. Now let me write the color. The color of SO2 gas is what? Colorless. Colorless. Then what is the odor? It has a choking smell. Choking what? Smell. It has a choking smell. Since it's an acid gas, so it will also be from blue to red. Now, if you have gotten the anion, tell me. Let me check the comments. Thank you. You have, some people got it. In fact, the best answer there is God's will's answer. That's the best answer. So SO2 is gotten from sulfite. Some people usually think it's from sulfate. It is not from sulfate. Take note, sulfate does not release any gas. It is sulfite that releases gas. And the gas that is released by sulfite is what? SO2. Don't forget. So you also have hydrogen sulfide gas. Hydrogen sulfide gas is gotten from what anion? Sulfide. It's gotten from sulfide. So what is the color of hydrogen sulfide gas? It is what? Colorless. It is colorless. So what is the odor? Of course, rotten egg. The smell of a rotten egg. It's an acid gas, so it will still be from blue to what? To red. What about NO2, nitrogen 4 oxide? Nitrogen 4 oxide is actually from which anion? Nitrate. What is the color? It is brown. Reddish brown or yellowish brown. So it is brown. What is the odor? It has a pungent smell. Then it's an acid gas from what again? From blue to red. Then let me add the basic gas. Now you have ammonia. Ammonia is a basic gas. Ammonia is from what ion? Now ammonia, let me just add it, it's not from an anion. Ammonia is from NH4, which is a cation. Ammonia gas comes out from a cation, not anion. Take note of this, which is ammonium ion. So what is the color of ammonia gas? It is colorless. What is the odor? It has a pungent smell. This is from red to what? Blue. This is from red to blue. Of course, hydrogen sulfide is actually from blue to pale red. The red is light, pale red, but we can still say red. So you should know these gases and where they are coming from. So very quickly, screenshot this. I want to rub. Say move on if you are done screenshotting. Say move on. If you are done screenshotting, move on. If you are done, say move on. Quickly. Okay, move on. All right. So you have remember, we're talking about anions. We're still looking at anions. Now, I want you to also know that what we have considered are for dry tests, right? Now, if you want to carry out wet tests, what is the criteria for carrying out wet tests? First, the criteria for carrying out dry tests is to use two reagents for dry tests, which is dilute HCl, conc H2SO4. And remember, your salt must not be present in water. That is for dry test. Now, for wet test, what is the criteria for carrying out wet test? The criteria for carrying out wet test is to prepare what you call sodium carbonate extract. Is to do what? Prepare sodium carbonate extract. To prepare for wet test. Wet test, you prepare sodium carbonate extract. Don't forget, for wet test you prepare sodium carbonate extract. They will ask you, why do you have to prepare sodium carbonate extract to carry out wet test? Why don't you just dissolve the salt in water and carry out your wet test? Why do you have to prepare sodium carbonate extract? The reason is because sodium carbonate extract will help you remove heavy metals such as lead, such as silver. It will help you remove heavy metals that may interfere with your reaction. It will help you remove what? heavy metal that may interfere with your reaction. Take note of what I'm saying. Take note of what I'm saying. So for wet test, you prepare sodium carbonate extract. Now, how do you prepare sodium carbonate extract? You mix sample of your salt with dry sodium carbonate. Your salt plus sodium carbonate. Your salt. So once you mix this your salt plus your sodium carbonate plus water, you heat it, then you filter. You filter. When you filter, your filtrate is what you call sodium carbonate extract. Your filtrate is what you call sodium carbonate extract. Remember what filtrate is. If you do this and pour it in your filter paper, you see a solid particle. That solid is your precipitate. The one that drops down is your filtrate. That is what you call sodium carbonate extract. Remember, sodium carbonate extract is used in testing for sulfate ion, and it is also used for confirmatory tests. It is used for testing for sodium and sulfate ion, and it is also used for what? Confirmatory test. Are you following me? Yes. Now you have known how to prepare the sodium carbonate extract, so which you can use to test for your sulfate ion. How do you test for sulfate ions using your sodium carbonate extract? To test for sulfate ion using sodium carbonate extract, you need two reagents to test for sulfate ion. What are those two reagents? You need barium chloride and hydrochloric acid dilute. The two reagents that are used in testing for sulfate ion under the wet test are what? Barium chloride and dilute hydrochloric acid. Now, what will you expect when you add dilute hydrochloric acid to your sodium carbonate extract? You would observe you add this to dilute to dissolve the particle a little. You add your dilute HCl to your filtrate to dissolve that particle a little. Then you add barium chloride. When you add barium chloride and you observe white PPT, and when you observe white PPT, you decide to add extra dilute HCl, and the white PPT remains. It means that you have tested for what? Sulfate ion. So what am I trying to say? To test for sulfate ion, you need these two reagents, barium chloride and this. So when you add barium chloride to this, it gives you white PPT. If the white PPT remains insoluble in HCl, it means that the anion you have found is sulfate. Another substitute for barium chloride and this, you can use barium nitrate and HNO3 dilute. So these two, is either you use this pair like this, or you use this in testing for sulfate. I hope that is clear to you. Yes. Remember, we said under the wet test can also be used as confirmatory test. Now, if you want to confirm, you can confirm the halides, confirmation of halides. How do you confirm halides? You can confirm halides using your wet test. That is to say, you carry your filtrate. You use your filtrate to confirm halides. Do you remember what halides are? Yes. The halides are the chloride ion, the bromide ion, and what? The iodide ion. Those are the halides. You can confirm them from your wet test. What are the reagents that are required for their confirmation? The reagents that are required for their confirmation is the reagent for halide is silver nitrate and what? HNO3. Silver nitrate and what? HNO3 are used in the confirmatory test of what? Halides. I hope that is clear to you. Silver nitrate and HNO3. Now, when you add silver nitrate to your sodium carbonate extract, if you add silver nitrate to your sodium carbonate extract and you observe white PPT, and that white PPT is soluble in HNO3, then let me write it. Filtrate plus silver nitrate, white PPT soluble in HNO3, then it means chloride is what? Present. If you add silver nitrate and it gives you white PPT, and you now add HNO3, you now get a soluble, a clear solution. Which halide have you gotten? The chloride. When you add silver nitrate and it gives you cream, not white, now it gives you cream PPT. You know cream is not pure white. It gives you cream PPT, and that cream PPT is partly soluble or partly soluble, or you say slightly soluble. So if it is slightly soluble in HNO3, then it means bromide ion is what? Present. If you add your filtrate plus your silver nitrate and you get yellow PPT, you get your PPT to be yellow, which is insoluble in HNO3, then it means iodide ion is present. That is how you can confirm for your halides using AgNO3 and what? HNO3. Is that clear? If it is clear, say move on quickly. If it is clear, say move on. Some people are leaving, right? If it is clear, say move on. Say move on. I'm almost done. I'll be summarizing very soon. If it is clear, say move on. Say move on. Say move on. Remember, after this video, I need you to drop a comment. The comment that gets the most likes, I'm going to send you something on the group. I'm going to pick you out and get your number from the group, and I'm going to send you something on that group. Sir, we are tired. Somebody say we are tired. I will soon be done. I want to quickly touch cations and I'll summarize there. All right? So now, can I rub this? Then another anion. You can confirm. You can also get. My light is going off, so it means I'll need to summarize now. I need to summarize now. My gen is almost going off. I forgot to get fuel. So, and I was hoping to finish. So what I'm going to do is that I'm going to snap my notes and send to you on the WhatsApp group, because the gen is about to off. And if you have followed us and you are yet to subscribe, don't forget, hit the subscribe button. Hit the subscribe button. Drop a comment after this video, and let me just move on till the gen goes off. But my gen is about to go off. I wanted to talk about cations. And I have wonderful mnemonics to give you for cations. For cations, you classify cations into 6 groups. You classify cations into how many groups? 6. And when you want to test for cations, the first test ammonium ion. Test for ammonium ion is the first test you do before cations. Why do you test for ammonium ion? You test for ammonium ion to avoid interference. Now, if you start testing for other cations, you may introduce ammonium ion in the process where ammonium ion is not present. So the first thing you want to do is to test for what? Ammonium ion. Wow. So I don't think you can still see very well. So I need to just end. It's unfortunate I forgot to get this thing. So can you still see? Can you still see? So that we can round off from here. If you can see, please forgive me to round off from here. You can see, right? Let's see how to round up from here. Now, in your test for cations, the first cation you want to test for is ammonium ion. How do you test for ammonium ion? You test for ammonium ion using the reagent sodium hydroxide. You test for ammonium cation using the reagent sodium hydroxide. I hope that is clear. When you add sodium hydroxide to your solution, and you observe the evolution of a gas with pungent smell, then that gas turns red moist litmus paper red to blue. It means that that gas is ammonia gas, and the cation present is what? Ammonium cation. So I'm just trying to be fast. There are a lot I should talk about, but let me just summarize by telling you that, one, if you want to test for cations, you need to prepare a solution of the sample. Take note. You want to test for cations, you need to first prepare a solution of the what? Sample. How do you prepare a solution of the sample? You need to bring your salt. When you want to test for a cation, you bring your salt. Dissolve that salt in water. If that salt is not soluble, you're going to be doing it till you get a salt that is soluble. You want to prepare the solution of your sample so that you can test for cations. One, dissolve that salt in what? Dissolve in water. Dissolve in water, both cold water. If it is not soluble in cold water, then dissolve it in warm water. If it is not soluble in water, then you try out dilute HCl. This thing I'm giving you exam will still ask you the order. So after you have tried water and it is not soluble in water, you try dilute HCl. If it is not soluble in dilute HCl, you try concentrated HCl. If it is not soluble in conc HCl, you try dilute HNO3. If it is not soluble in dilute HNO3, you try conc HNO3. If it is not soluble in conc HNO3, it must be soluble in the last one. Then you try what we call aqua regia. Try what we call what? Aqua regia. What is aqua regia? Aqua regia is a mixture of 1 volume of HNO3 and 3 volumes of HCl. That is aqua regia. Aqua regia is just a mixture of HNO3 and HCl in this proportion, 1:3. So they would ask you, which of the following is the correct order in preparing your solution of sample for cation, for test for cations? This is the order from water to this to this to this to this to this to this. They can decide to pick just these 3 and these 4 and ask you which is the correct order. So don't forget, you first prepare a solution of your sample. Now you need to understand that for cations, so screenshot this, for cations, your cations are classified into 6, and that is where I'm going to stop. I have much to talk about, but some people are complaining of data, so I'm going to stop here, and this is important. Your cations are classified into how many? Into 6. They are grouped into 6, not the group you have in your periodic table. They are grouped into 6 based on their precipitating reagent. Cations are grouped into how many? Into 6 based on their what? Precipitating reagent. So we have group 1. We have group 1. Group 1 cations. I have mnemonic that can help you remember these things. Group 1 cations, I usually ask myself, I hope you know that anytime you are hungry, one of the things you notice is that hunger leads to anger. You notice that what? Hunger leads to what? Anger. Hunger leads to what? Anger. Don't forget. Now, what does this mean? This H means that group 1 members are H, which is mercury, Hg. Then leads is for lead, so which is Pb2, that is group 1. Then Ag is for silver, So it means that your group 1 cations, you can remember them using hunger leads to what? Anger. What are the cations? Mercury, lead, and what? Silver. Don't forget. Now, what is their precipitating reagent? That is to say, the reagent you add to it to bring them out of solution. What is their precipitating reagent? The precipitating reagent is dilute HCl. Their precipitating reagent is what? Dilute HCl. Then you have group 2. Group 2 again, I also have another mnemonic I used to remember it. Group 2, I know that hunger leads coppers, youth coppers, you know youth coppers. Hunger leads coppers to biting. Hunger leads coppers to what? Biting. Again, what do you think H means? H again means what? Mercury. Then lead means what? Lead, like you know. Then copper is copper, like you know. Then you have biting, which is bismuth. Bismuth, don't forget this. Hunger leads coppers to biting. If you are hungry, you want to bite. True or false? True. Mercury, lead, copper, bismuth. Hunger leads to biting. Don't forget. What is the precipitating reagent of group 2? The precipitating reagent of group 2 is hydrogen sulfide in acidic medium. Hydrogen sulfide in what? Acidic medium. Very quickly, group 3. Group 3, I usually say all cramming. All cramming leads, or rather, all crammers fail. All crammers do what? Fail. Anybody that crams always do what? Fail. All crammers fail. So all you should know is for aluminium, right? Aluminium has a charge of +3. Cram is for chromium +3. Now, one special thing about group 3 is that most of them, their charges are 3, 3, 3. So aluminium 3, chromium 3. Then fails is for iron. Iron is 3, and then iron 2 is also there. So all crammers do what? Fail. So you should remember group 3 with this. What is their precipitating reagent? Their precipitating reagent is ammonium hydroxide. It's ammonium hydroxide. Quickly, group 4. Group 4, how do you remember group 4? Very quickly, group 4 is what I call nickel, the zinc man. Nickel, the what? Zinc man. That is what I used to remember. I have a friend that usually likes to climb zinc, and his name is Nicholas. Nickel, the zinc man. So how do I remember this? I have nickel. This is nickel. This is nickel. This is cobalt. Then zinc, of course. Then manganese, right? Yes, I have this. And what is their precipitating reagent? Their precipitating reagent is what? Is hydrogen sulfide again, but this time in alkaline medium. Alkaline medium. I'm almost done. Once I give the last two now, I will end this video. So be patient. Then group 5. I hope I can rub this. Are you still following me? Are you still following me? What I'm explaining, say thank you. If you're getting it, say thank you. If you're getting it, say thank you. If you are getting it, say thank you so that I can rub. I want to rub this and add the last two. Thank you. Thank you. Thank you. Now you have the last two. That is group 5 now. So group 5. So group 5. Group 5. Now for group 5, how do I remember group 5? In UNN. There are people that usually go to lawn tennis to pray. When I was an undergraduate, we usually go to lawn tennis to pray. And in UNL, what we usually call prayers is what? Kabash. I want to go and kabash. I want to go and kabash. So I use that again to remember. Kabash. Kabash, right? Where Ka is what? Calcium. Bash is what? Barium. And this is what? Strontium. This is strontium. So that is my group 5. What is their precipitating reagent? Ammonium carbonate. Ammonium carbonate is their precipitating reagent. And finally, group 6. Group 6. How do I remember group 6? That one is very funny. For me to remember group 6, what I simply say is Maggie, that is in pidgin now. Maggie na key to ammonium. Maggie na key to ammonium. That is to say, Maggie is the key to ammonium. Maggie na key to ammonium. Maggie na key to ammonium. So Maggie is magnesium. Magnesium. Then Na is what? Sodium. Then K is potassium. Then ammonium. So these are these. And one special thing about group 6 is that they don't have any precipitating reagents. Why don't they have precipitating reagent? Because they are all what? Soluble. They don't have any precipitating what? Reagent. So I believe this is very clear. I have more, but I'm going to snap some questions and send to our WhatsApp group. So at this point, I'm going to end this video. I want to appreciate everybody that stayed through in this video from the start till the end. I'm doing this to really support you and to see that you make good grades in your exams. And I'm sure one of the ways you can also encourage me and support this channel is by always sharing my videos, subscribing if you've not subscribed, hitting the like. Nothing should stop you from liking anytime you come across my videos. Drop a comment. Now, I told you I have a gift for you. And what I'm going to do is, by the time we end this video, not now, immediately I upload this video, come back to the video and drop a comment. Of course, you don't know how much I want to give out. I'll be doing a giveaway. The person's comment that gets the most like, I'm going to give you some money. So do well to comment so that you see if you can be the lucky winner. And let's look at likes from 30 likes and above. From 30 likes and above, the person that gets the most like above 30, you get something from me. Thank you, and I wish you great success in your exam. Tomorrow, don't forget, tomorrow being Monday, we're going to have another live session. I don't know the time yet. I might fix it by 8 p.m. So that I'll do it 8 to 10. I'm going to put on Gen so that everywhere will be bright. So tomorrow, we're going to have another live session for Physics 101 against Tuesday. Don't forget to be present. Thank you. See you in my next video. This is Prime Concepts. So those that say they are not on my group, you say you're not on my group, quickly, I will drop the WhatsApp link on this, under this post. I'll drop it. So through that link, you join the group so that you participate. All right, thank you to every one of you. I can't appreciate you one after the other, but I appreciate everyone. Ebube, Zikora, Peace, Enot, Chimaku, Chidebube, Abokinsley. I appreciate every one of you. Esther, Justice, Obonna, Pascal, Zikora, Blessing, Chimaku, Ubute, thank you, Uchechi, Elvin, thank you. So I'll be ending now. Thank you. I'll drop the link to the WhatsApp so you join the WhatsApp group through that. Thank you.